The depth of detection is a very interesting topic. The first thing to know is there are many parameters in your environment that can affect the depth. For example, if the soil is mineralized, if it's polluted or clean, wet or dry, or if it's compacted or airy. Plus, these characteristics can sometimes vary if you move just a few meters. The type of target also has a big impact on the detection depth. The results can differ depending on size, weight, or conductivity, or even its shape and the position in the ground. The program used and the adjustments made are obviously important, as well as the coil you've chosen. And here, I'll skip many other factors that can influence detection depth. The goal of this video is to use several field tests to better understand detection depth, and that under optimal conditions, the DEUS2 can locate targets very deep. You have to understand it's impossible to run tests on the detector's power that will work for every environment. The results of these tests relate to the conditions in which they were made. In my case, the soil is not mineralized. I also took care to leave the ground as undisturbed as possible. To do this, I made a cut. Then I drilled small holes at different depths to insert the targets. Keep in mind that when looking for deep targets, it's necessary to be more focused and sometimes investigate suspicious sounds. This is the key to finding targets at the limit of detection. Now let's talk about coils. They are not all equivalent for deep searching. Let's run a test to illustrate this. Starting with the 28-inch coil and the original Deep HC program, the target is a 30mm bronze coin with an ID of about 88. Let's try the target at 40 centimeters deep. Let's try now with the 22-inch coil. The test result speaks for itself. On this field, the 28-inch coil is slightly more powerful than the 22, and this is simply due to the coil's larger size. So with this coil, we have a slightly deeper result on clean ground. We're only talking a few centimeters, but on some scenarios, it can make all the difference. My test area has a clean, non-mineralized soil. The mineralization strength meter remains empty, and the soil value registers an 87, even after an adjustment by grabbing. For the following tests, I'll use the 28-inch coil, which is currently the largest available for the DEUS2. Let's use the sensitive program with no changes made, starting at 30 centimeters. We can get it with an ID of 85, and I've now moved it to 35 centimeters. We still have it, but this time the ID is much lower at around 30 or 31. Let's move down to 40 centimeters. The sound is a little weaker, but we still have it, 45 centimeters. We still have it, but really this is at the limit of detection. The sound is very weak, slightly sputtering and irregular. I think that most users would pass this target by. Acceptable tones up to 45 centimeters deep with a factory preset. This proves that even without making extensive adjustments, the DEUS2 can find very deep targets. Let's continue the test with the Deep HC program, which uses low and medium frequencies up to 14 kilohertz. It's perfect for this kind of deep target. Same result, we're at the limit of detection. I will now optimize my settings by lowering the reactivity to 0.5, which gives the detector a little more time for its analysis, thus increasing the detection limit. I will raise the sensitivity to 95 to once again push this limit. If the detector remains stable, you can increase this setting further. Conversely, reduce it if you receive too many false signals. I will increase the audio response to 5. This setting does not affect the power, it only increases the volume of deep targets, making you more aware of them. We managed to improve the signal. Let's move down to 50 centimeters. We still managed to hear the target, but once again at the limit of detection. We are 50 centimeters down with a 30mm bronze coin. Just by making some adjustments, it's easy to gain more detection depth. Just be careful not to go overboard. It's always a matter of compromise. If you push the settings too much, the detector can become unstable, making it difficult to discern a small, deep target from false signals. It is clear that it would be impossible to detect under these conditions. All this to show you that depending on your terrain, you can more or less push the settings and thus potentially find targets more or less deep. We will now test another target. I will use a gold coin, 19 millimeters in diameter. It has a lower conductivity and an ID around 66. I will put this one at 20 centimeters deep and start with the sensitive factory program. We have a nice sound with an ID between 66 and 67. Now let's try at 25 centimeters. It's a little more complicated, though we still manage to get a sound. Let's try 30 centimeters. At 30 centimeters, the detection limit is reached. This is a very good result for this type of target. Let's test with the Goldfield program next. It's very important to adjust the ground balance when using the Goldfield program. In my case, the soil is not mineralized at all. The value remains at 87. We managed to get a slight signal, but let's try to optimize the Goldfield settings. I will lower the reactivity to 0.5 and raise the audio response to 5. We managed to improve the signal, but it's important to know that Goldfield is basically an all-metal program. It can be complicated on certain grounds. Let's increase the discrimination, IAR at 2. No problems. Let's try it with a setting of 5. This way, all the ferrous materials will be rejected. We always get the target, but hear a slight low tone from time to time. The deep target begins to register as iron. I will lower the discrimination to 2 and continue to test at 35 centimeters. We can still hear it. Let's try 40 centimeters. This time, we have reached the detection limit. Now let's do a test with a tiny target made of copper, with a diameter of 9 millimeters weighing only a quarter gram. It has low conductivity, ID around 44, so it's a very difficult target. Let's start the test at 10 centimeters with the factory sensitive program. At 10 centimeters, I can get the target with an ID of 41. Now let's try 15 centimeters. We can tell that the sound is weaker, but we can still hear it with an ID of 41. Let's move on to 20 centimeters. We no longer have the target. 15 centimeters may not seem like much, but believe me, this tiny target is extremely difficult to detect. Actually, the result is pretty good, especially since I didn't change any settings. Now let's optimize the settings of the sensitive program. I lower the reactivity to 0.5, the audio response I turn up to 5, and I increase the sensitivity to 95. We can get a slight sound, but 20 centimeters is the limit of detection. This is a great result for this type of target. Let's try it now with the mono frequency program and optimize settings. So we go to 40 kilohertz, a reactivity of 0.5, audio response of 5, and sensitivity of 95. We managed to have a good sound. Let's try 25 centimeters. We can see that we now have a better result with the 40 kilohertz mono program. It makes sense. This program uses a single frequency, so it's focused only on 40 kilohertz, and it allows us to have very good performance on small, low conductive targets. But don't forget, the mono programs are much less versatile than the multi-frequency programs. For example, let's try this 30mm bronze coin at 40 centimeters with the same mono program. Let's try now with the sensitive program in the same settings. The result is clear. We have a much better signal with the multi-frequency sensitive program because it uses high frequencies but also more efficient average frequencies on sites with good conductivity. So far, we have done tests on a clean, non-mineralized soil. We will now make a test with the gold coin at a depth of 15 centimeters, and these pieces of clay pot will replicate mineralized soil. Let's start with the factory sensitive program. It's very difficult to hear the coin. It's only 15 centimeters down, but these fragments of pot partially hide it like magnetic soil can. We're going to make some adjustments to get it right. We'll start by grabbing, so I've removed the target. There, I now have the ground set to 83. It's a little better, but that's still not it. I will now use the ground stability setting. Initially, on the sensitive program, it's set to 2. Let's change it to 1. It's way better. We even got an ID of 61. We will now try to gain a little power by lowering the reactivity to 1.5. With the signal I had at the start, I don't think I would have dug that target. Now, I would dig it for sure. This test shows that depending on the type of terrain, the detection depth can be totally different. For example, on mineralized soil, to have this gold coin at 15 centimeters is already an achievement, but on clean, non-mineralized soil, we can easily double that. We will now run a new test. I removed the clay, but this time added nails to simulate a polluted ground. This is an extreme test because I positioned no less than 8 nails all around the target. Let's try without the target with the factory sensitive program. The nails are well discriminated. I will now add the target, a gold coin at 15 centimeters deep. We can't hear the target. Now let's try to increase the reactivity to 5, the maximum. We can now hear the target, though it is a bit drowned out in the middle of the low sounds. For this test, I used the 22-inch coil because it's much more efficient for this type of situation. Let's try it again with the 28-inch coil. I'll increase the reactivity to 5. Much more complicated to get the signal because the 28-inch coil amplifies the masking of the target on a polluted ground. Therefore, it's more beneficial to use the 22-inch. Let's try to scan the target more precisely. When scanning more precisely above the target, we manage to get a good signal. The high reactivity allows us to hear the target in the middle of the iron. Then all we have to do is tighten up the scan to better identify it. This test proves that on polluted ground, a high reactivity must be used. Otherwise, there is a good chance good targets will be masked. The 2 previous tests show very well that depending on the type of terrain, the adjustments that we make to optimize a program will be different on clean, non-mineralized ground. For example, the detection depth will increase from a low reactivity setting. On the other hand, on polluted ground, we will try to limit masking with a high reactivity setting. And finally, on mineralized soil, we will ground balance to find a stable ground setting to be as free as possible from the ground minerals. So far, we have done tests on common targets, but now let's look at the detection depth of the Deus2 on large masses like this metal box. Of course, the test ground is totally clean. For this test, I will use the factory relic program. It's perfectly adapted for this type of searching. In this program, it's very important to adjust the ground balance precisely. I have a setting of 85, which is perfect. Now we can start the test. The target is at a depth of about 75 centimeters. No problem, I have a good signal. Let's try it by lifting the coil. We easily have the target, even with the coil 20 centimeters off the ground. Now, I'll increase the IAR discrimination to 3. We hear the target perfectly. Let's try 4. Even with a discrimination setting at 4, it is easy to hear the target without any low tone. Now, let's try 5. Unfortunately, we now hear a low tone. Because of its depth, the target has a signature that's close to a ferrous target. It's therefore partially rejected by setting the discrimination to 5. It's preferable to reduce it to 3 or 4. This way, we will reject a large part of the iron without degrading the good deep signals. Now let's try the single frequency program. I'm at 4.4 kilohertz with a sensitivity of 95, audio response at 7, and reactivity is 0. I also did a grabbing to adjust the ground balance. We only have a low tone. The relic program is therefore the most suitable for this type of searching. Now I'm going to try to put the target a little over 95 centimeters deep. I lowered the reactivity to 0 and increased the audio response to 7. We have reached the limit of detection, but we still managed to hear a slight signal at almost 1 meter deep. The DEUS2 can therefore easily find large masses at record depths. We will now change the test location. This soil is still clean and not mineralized. However, since the last storm, deep down it's soaked with water. Let's start with the Deep HC program and optimized settings. For the moment, I have not inserted any target. These tiny signals we hear are due to the humidity of the soil. Under these conditions, it is impossible to search for deep targets because the ground emits too many false signals. Let's try this time with the factory settings. This is better, but the machine is still too unstable for deep searching. Now let's test the stability of the sensitive program. It is much more stable thanks to the notch of the sensitive program set to remove false signals due to soil moisture. I will now optimize the settings without going overboard. In this case, the machine would become too unstable. I put the sensitivity to 93, reactivity to 1, and audio response to 5. There are still some small instabilities, but it's usable. Let's do the test with the 30mm bronze target at 30 centimeters deep. We hear the target without any problem with an ID of 87. Let's go to 35 centimeters. It gets more complicated and we have a small sound, but let's try at 40 centimeters. We have a light sound, but not very convincing, not something we would actually dig. Thanks to the sensitive program and its notch, we managed to have a stable program and even optimized the settings to hear a target at 35 centimeters depth. Most of the programs we've used today are in the frequency addition category. Now let's try one with subtraction of conductive soils. Let's look at the stability of the general program without any targets. Thanks to the subtraction of conductive soils, the detector is totally stable. Let's try to push the settings. Let's set the reactivity to 0 and the audio response to 7. Even with these settings, the program is completely stable. Let's try with a target at 40 centimeters. We have much better results with the general program. The stability brought by the subtraction of conductive soils allows us to push the settings further. Now let's try 45 centimeters. And we still managed to get it. Now let's look at the Relic program, which also has subtraction of conductive soils. It's equally stable. Let's optimize the settings. Increase the sensitivity to 97, reactivity lowered to 0, audio response set to 7, and ground balance. No change, still 87. Let's try 45 centimeters. We still hear a slight signal. Let's go further and push the test, try 50 centimeters. Well, here in this configuration, we have reached the limits of the machine, but we're at 50 centimeters. We can therefore conclude that on wet land, programs with subtraction of conductive soils are much more stable than the others. Let's try now with the mono program at 8 kHz without any targets. No false signals, because low frequencies do not produce instabilities on wet ground and directly optimizes the settings. So, we're set at 8 kHz. Reactivity is 0, audio response is set to 7, and sensitivity at 95. Let's start directly at 40 centimeters to compare it to the multi-frequency program. The signal is quite weak with lots of low tone, and we've reached the limit of detection. In these conditions, the multi-frequency programs, General and Relic, give better results. To conclude, it's very important to choose the right program, and on this ground, it's not necessary to look for the most powerful one. You will find more targets by optimizing the stability and the selectivity of your detector. It's necessary to find the right compromise between power, stability, and selectivity. The better you know the field you're on and your detector settings, the better you will push the limits of metal detecting. As for the performance of the Deus2, these tests are amazing. In some situations, it would even be possible to further improve results. The Deus2 is perfectly suited for deep targets on all terrain. I hope you enjoyed this video, and if so, please subscribe so you don't miss the next ones. See you soon.